We are now ready to talk about some of the rules that we can use to simplify exponential expressions. And the first one is one you see on the screen, a to the m times a to the n equals a to the m plus n. It's a rule that you should commit to memory. So first, let's talk about what this rule means, and then we can talk about in what ways could we make use of this rule. What the rule basically means is when you multiply, right, this is multiplication. When you multiply two exponential expressions and they have the same base, right, the same number that's raised to a power, what you do is you keep the base and you add the exponents. So, for example, if you have something like 3 to the 5th power times 3 to the 2nd power, you could technically say, well, you're multiplying exponential expressions, they have the same base. We could keep that base, add the exponents. 5 plus 2 is 7. So 3 to the 5th power times 3 to the 2nd power is equal to 3 to the 7th power. Now, this is something that you can take as a rule, but what you can also do is use the fact that we can rewrite each exponential expression as repeated multiplication to see exactly why the rule is true. When you have 3 to the 5th power, what you're doing is you're multiplying 5 threes. 5 threes. And you multiply that by 3 to the 2nd, which is 2 more threes, right? This part right here was 3 to the 5th power. This part right here is 3 to the 2nd power. And when you multiply, well, of course, you have 5 and 2, 7 threes. So 3 to the 7th power. You add the 5 and the 2. This demonstration should hopefully give you an idea of why the rule works the way it does. Now let's take a look at a few more examples of how this rule could be applied to simplify expressions. Let's look at example 5. We have x to the 3rd times x to the 2nd. Notice we have the same base, x. If this was an x to the 3rd times, for example, y to the 2nd with different bases, there wouldn't be much we could do. But here we can say keep the base x, add the powers, 3 and 2, makes it x to the 5th power. Right? Nice and easy. Again, if we wanted to think of x cubed as x times x times x, and x squared as x times x, of course, when we multiply these, we see there are 5x's, x to the 5th, right? You can always use this logic if you aren't sure, if you don't remember the rule. You can always rewrite things in exponential, that were in exponential form as repeated multiplication and make sense of it yourself. Let's take a look at another example. Example 6, 4x to the 5th y squared times 7x squared y cubed. What will help you with this example is to remember that even though you only see just one multiplication sign, really everything is multiplied, right? It's 4 that's multiplied by x to the 5th, that's multiplied by y squared, that's multiplied by x squared, multiplied by y cubed. And because everything here is multiplication, and in multiplication, order of operations, or order doesn't matter, right? You could, for example, if you had something like 2 times 3 times 5, You could change the order, multiply 2 by 5 first, and then multiply the result by 3, right? The order doesn't matter. What you can do is you can just multiply the things that would make sense to multiply, things that you can simplify, like you would multiply 4 by 7, because you can simplify that as 28. You could multiply the x's, which means you keep the base, add the exponent. 5 plus 2 is 7. And the same thing with the y's. Y squared times y cubed is y to the 5th. Just keep the base of y, add the exponents. So when you see something that's a little bit more complex, remember, just multiply what you can multiply, and you can't really do anything else, right? You could try to multiply 28 by x to the 7th, but there's no rule that helps you simplify that, right? Just like there's no rule that helps you simplify x to the 7th times y to the 5th. You can't make up a xy to the 12th or something like that, right? They have different bases. Can't do anything about it. Let's take a look at one more example. So in this example, you don't have just one term that you're multiplying by 3x squared. You have 3 separate terms, which means you can make use of the distributive property to distribute the multiplication of 3x squared into each of the terms. Well, 3x squared times x squared is 3, and x squared times x squared is x to the 4th. Remember, you're adding the exponents, 2 plus 2. Next, we're going to multiply 3x squared by minus 6x. So 3 times minus 6 is minus 18. Now, when we multiply the x's, x squared times x, don't forget this is like saying x to the power of 1. And when we add the exponents, 2 plus 1 is 3. So that's x to the 3rd power. And finally, 3x squared times 3. Well, 3 times 3 is 9. And we just have the x squared. There's nothing more that we can multiply it by to simplify. And so our answer is 3x to the 4th minus 18x cubed plus 9x squared. Notice that there are no like terms in our answer, so I can't simplify any further. Okay, well, that's all for this rule. You now know that to multiply exponential expressions that have the same base, you just keep the base and add the exponent. The next video we'll talk about division.